All right, so here's our example number 3 in 16.1. We're going to do two more parts here in example 3A and B to get us a little more practice with our integration by parts. You might also notice that this example is a little bit different than the other two we've done so far. Because we have limits of integration. So not only do we have to use our integration by parts, we then have to evaluate this integral from 1 to e. Okay? All right, here we go. I noticed that in this problem, I have actually a quotient rule. Doesn't it look like a natural log of x divided by x squared? You could actually think of this as a quotient rule or a product rule. I could actually rewrite this problem into the natural log of x times x to the negative 2, can't I? Then I have a product rule where if I tried to use u substitution, it wouldn't quite work. I'd have some extra stuff in there that I wouldn't be able to get rid of. And so then I notice that my only other option when I have a product rule is integration by parts. So looking at this problem, if I'm using integration by parts, and so there's the formula there in the red and the blue, we've got to figure out what our u is going to be. We've got to figure out what our dv is going to be, find all four pieces then, and then fill in our pieces so that we can evaluate. So in this problem, we've got to figure out what our u is. Remember the three letters, L, A, E. The first thing I notice is that I do have a natural log in this problem. I have the natural log of x. So that's what I'm going to start with, and I'm going to call u natural log of x and hope that all the pieces fit together. If the natural log of x is my u, then that means the rest of it is my du, right? So that means 1 over x squared, or you could say x to the negative 2 dx would be your dv, right? Okay, so if u is the natural log of x, then the derivative of any natural log problem is the derivative of the inside over the inside. So the natural log of x, the derivative of natural log of x, is 1 over x dx. If my dv is 1 over x squared, or you could say x to the negative 2, then the antiderivative, the integral of that, would be x to the negative 1 divided by negative 1. You can manipulate that a little bit and eventually get negative 1 over x if you wanted positive exponents. Okay? All right, now that I have all four pieces, I could say then that my problem is u, which is the natural log of x, times dv, which is perfect because that's what my integration of parts formula calls for. As long as I have a u times dv, well then I can figure out what it equals by doing the rest of the integration by parts formula. That's u times v, that's the natural log of x, times the negative 1 over x, minus v times du. V was the negative 1 over x, and du was the 1 over x dx. Let's simplify a little bit. I end up having here a negative 1 on the top. If you were to put this into two fractions and they're being multiplied, numerators multiply with numerators and denominators multiply with denominators. So on the top I have a negative 1 natural log of x over x. My integral, when I simplify it, ends up being a positive. Do you notice where I got that positive from? This negative and this negative make me a positive in between, and then I have a 1 over x squared. My first piece doesn't really simplify anymore. Please don't cancel out those x's because then you just split apart the natural log and his variable that he has to go with. But my integral, let's see here, could I call this then x to the negative 2, just like we did over here when we did our dv? And so that means if I want to find the antiderivative of x to the negative 2, or the integral of x to the negative 2, I would end up getting negative 1 over x. So now I have this green expression that's using my integration by parts. My integration by parts is done, but I didn't add a plus c this time because I have my limits of integration. Remember from the beginning of the problem, we wanted to evaluate this problem from 1 to e. We wanted to find the area underneath the curve from 1 to e. What that means is we have to use our fundamental theorem of calculus, right? We've got to plug in our upper limit, then we've got to plug in our lower limit and subtract. So I'm going to take this expression, I'm going to evaluate it with e, plugging in e everywhere I see an x. Then I'm going to plug in a 1 everywhere I see an x, and then I'm going to subtract the two pieces. All right. You might know without a calculator, but even with a calculator, if you try to do natural log of e in your calculator, if you punch that in, we should all have a natural log button, we should all have an e button. The natural log of e happens to be 1. So I end up really with a -1 over e minus 1 over e for that first piece. If you try to do natural log of 1 in your calculator, you actually end up getting 0. So the natural log of e is 1, but the natural log of 1 is 0. That's helpful to know. Now this piece then turns into a 0, minus 1. All right, combining some like terms here, I ended up getting a -2 over e. That's a -1 over e minus another 1 over e is a -2 over e. That's combining my like terms, keeping my common denominator, and just subtracting the numerators. In my parentheses over here, I have a 0 minus 1, which is a -1. And then remember, I'm subtracting it. And so then those two negatives eventually make a positive. So I end up with a -2 over e plus 1. That would be my answer in exact form. Or I can put that in the calculator and round it to whatever decimal they ask me for, and I ended up getting 0.264. And so the integral of my original problem, natural log of x over x squared, from 1 to e is really 0.264. Not only using my integration by parts, but also using my fundamental theorem of calculus to evaluate. All right, let's do one more here where we're evaluating again, and it looks like we're evaluating again from 1 to e. All right, so in this problem, actually this problem looks really similar to the last problem. The only difference now is that my x squared is already at the top. It's not in the bottom anymore. But you might notice that I have two functions being multiplied. I have an x squared times a natural log of x. Two variables, two functions being multiplied. And since I see that, and I know that there is no such thing as product rule, that's how I know I'm going to try my integration by parts. Let's decide what u is, let's decide what dv is, and then let's use our integration by parts. So why don't you try to pause the video and see if you can pick out u and dv, and then du and v. All right, remember your LAE. I know that you see some algebra in there, the x squared, but before I see that, I see a natural log of x, so that's what we're going to call u to start with. If that doesn't work and our pieces don't fit in our formula, then maybe we can try something else. But if the natural log of x works with all the other pieces, then that's what I want to use. So if I use natural log of x to be my u, then that means the rest of it should be dv. That means the rest of it is x squared dx. If u is the natural log of x, then the derivative would be the derivative of the inside over the inside, or 1 over x dx. If dv is x squared, well then the antiderivative, the integral of x squared, is x cubed over 3. Okay, so now that I have my four pieces, I can go ahead and plug into my equation because now I have u dv and I'm integrating from 1 to e, and I know that's the same thing as this, evaluating it from 1 to e. All right, here we go. Let's plug in our u. Let's plug in our v. Minus the integral of v times du. Let's simplify a little bit. So in my first term here, I had an x cubed in my numerator times the natural log of x all over 3. In my second piece, I had an x cubed in my numerator. I also had an x in the denominator. So maybe you notice that I reduced an x from the top and an x from the bottom. That left me with an x squared on the top. And then I actually had a 1/3, 1 over 3, that I could take out as a coefficient. So now I have the integral of x squared. That's not a product rule, it's just a basic power rule with integration, and I know that the antiderivative of x squared is really x to the third over 3. You might have noticed that it turned into a 9 because I already had a 1/3 out in front. So if I have an x cubed over 3 and I multiply it by another 1/3, I really end up getting x cubed over 9, right? Don't forget though, we are integrating and we are evaluating from 1 to e. So I didn't add a constant of integration. I'm not quite done yet, even though my integration by parts is done. I still have to use my fundamental theorem of calculus to plug in an e and then plug in a 1, my upper limit, my lower limit, and then subtract them. So I'm going to take this expression, and wherever I see an x, I'm going to plug in an e. I'm going to take this expression, wherever I see an x, I'm going to plug in a 1, and then I'm going to subtract those two expressions. Remember, the natural log of e is just 1. So I end up with e cubed over 3 minus e cubed over 9 minus, remember the natural log of 1 is 0, so that whole term turns into a 0. And then I really have a 1 over 9. It's a negative 1 over 9, but if I were to distribute this negative through, the negative and the negative make me a positive. That's why it's a positive 1/9 in the orange. I have a couple different denominators here. I have a 3 and a 9. So what I'm going to do is get a common denominator. I'm going to make all of those denominators into a 9 so I can combine those. So I'm going to multiply the first term by 3 over 3. So if I have a 3e cubed over 9 minus 1e cubed over 9 plus 1 over 9. A 3e cubed minus 1e cubed is really just a 2e cubed over 9 plus 1/9. I guess you could put those together and you could call that an 2e cubed plus 1 all over 9. That would be the exact answer. Or you can put it in your calculator and round it to whatever decimal place they ask you. So just make sure you follow the directions on my math lab to see if they want it in exact form or if you need to then take this and put this in your calculator. I forgot to do that, so I'm not exactly sure what the decimal is, but you can do that. 2e cubed plus 1 all divided by 9. So depending on how they want their answer. All right, lots of different steps in these problems. That means lots of different places for silly mistakes and errors, so please be careful. Make sure that you practice. Make sure that you practice going through all of these different steps, and make sure you show me all of your work. It is going to be really hard for me to give you partial credit on your exam if I can't figure out what the heck is going on, especially with all of this stuff going on. So please make sure that you're clear and you label your U, DU, V, and DV. Make sure that you're clearly showing me all of your steps, step by step, so I can figure out what you're doing. And if you make a mistake, I can try to follow along and still give you credit for doing the process right. Maybe you just messed up on a minus sign, right? But if I can't figure out what you're doing, I can't give you partial credit back. So please make sure that you show me everything you have so I know how you got the right answer, or if you got the wrong answer, if I can give you partial credit back, okay? All right, we're almost done. Hang in there. Let me know if you need anything, and make sure you practice by doing your homework.